Yes, sir.
Yes, sir.
This one. So last topic that we have seen is V is equal to U plus AT. Just for the sake of recollection, let me do it again. So the heading is nothing but derive equations of motion of an object having constant acceleration using calculus method. Right, that is what we need to do. Now listen to this carefully. So what is the first equation of motion? V is equal to U plus AT. So if I start at this point A and go to this point B, if I say the velocity here is U and the final velocity here is V, I will take this as V initial and this as V final for the sake of better understanding. And T initial, I will take it as 0. T final, I will take it as T. Okay. So whenever you're deriving the first equation of motion, you should always start with the definition of acceleration. If you're using graphical method or slope method, then we'll go with the concept of the average acceleration. Now we will go with instantaneous acceleration. So A is equal to dV by dt, which implies dV is equal to A into dt. Okay. See, this method is basically called as variable separable method, but you will learn this only in your 12th standard. You can just have this name in your mind for the time being. You need not worry much about what this is. It's called as variable separable method, meaning you take one of the differential coefficients to the other side and solving it. Because you're separating the variables, that is why it is called as variable separable method. So after you attain this step, you need to integrate on both sides. So when you integrate on both sides, you get integral of dV is equal to integral of A dt. So what is the value of dt? Like if I take the initial time, the corresponding initial velocity here was Vi. If I take the final time as Tf, the final velocity will be Vf. What is the integral of dV? It is V between V initial to V final is equal to, what did I say the topic is? Of an object having constant acceleration. So whenever the acceleration or any variable is a constant, that will come out of the integral A into integral of dt from Ti to T final. So what does this step tell? So you'll substitute the upper limit V final minus V initial is equal to A into T final minus T initial. So V final is V, V initial is U is equal to A into T final is T minus T initial is 0. So V minus U is equal to AT, which implies V is equal to U plus AT. Okay. This is a known quantity. Next. For second equation of motion, what is the second equation of motion? S is equal to ut plus half at square is there, right? So for S is equal to ut plus half at square, we will take the definition of instantaneous velocity. So what is the value of instantaneous velocity? Can I write it as ds divided by dt? But we already know that v is equal to u plus at is equal to ds by dt. Guys, are you able to understand or not? Am I clear?
Yes, sir.
Yes.
Okay. So which implies, what should I do? ds is equal to u plus at into dt. Now what will be the next step? Integrate on both sides. So integral of ds will be equal to integral of u plus at into dt. or it will be integral of u dt plus integral of at dt, right? So it is like this: integral of f of x plus g of x into dx can be written as integral of f of x dx plus integral of g of x dx. Okay, so I separated and wrote it like how you differentiate them individually and then add. Similarly, you can integrate and add them. Okay, so this is a crucial step. Observe here the variable is time. Here also the variable is time. Here the variable is displacement, right? So if I take 2 points A and B, if I say the initial displacement of the object is SI is equal to 0, and the final displacement of the object S final is equal to S, and if I take T initial to be 0 and T final to be T, now observe what I can do. So when the time here was Ti, what would have been the corresponding displacement? It would have been
0.
SI. No, I write it as SI first, then I will substitute 0. So similarly, when the time here is T final, the displacement here is S final. So what is integral of ds, guys? What is integral of ds? Integral and derivative are opposite operations of each other. So integral of a derivative will be the value itself. So S from where to where? From SI to S final is equal to U is there, U will come out of the integral. So U into integral of dt from T initial to T final plus out of acceleration and time, will acceleration come out, time come out, or both will come out?
Acceleration is constant,
Acceleration.
sir.
Only acceleration alone will come out because here the function is time and you cannot take time outside. So time is a dependent quantity here. See, time is a dependent in terms of mathematics, yes. Plus a into integral of t dt from where to where? T initial to T final. So substitute the upper limit. S final minus S initial is equal to U into T final minus T initial. Okay. Sorry, I should have written another step. U into integral of dt is how much? T between T initial to T final plus A into what is integral of T dt? What is integral of x dx? I think I have taught this already, right? X power n plus 1 by n plus 1. Here n is 1. So
It
x
is
square
t cube by 3.
it is t square divided by 2. T power 1 noda. Integral of t dt is t square divided by 2 between t initial to t final. So S final minus S initial is equal to U into T final minus T initial plus A by 2 into T final square minus T initial square. Okay. So now substitute all the values. SF is equal to S, SI is equal to 0. So S will be equal to U into T final is T minus 0 plus A by 2 into T square minus 0. So S is equal to ut plus half at square.
Sir, I have a doubt. So
What
can
is
you
it?
scroll up a bit?
Yeah.
Yes, sir. Here integral of d
Mhm.
and derivative of t, right?
This one, huh?
Yes, sir.
See, that is not integral of t into derivative of t. That is read as integral of t with respect to t. Based on the variable only, you will say which is a constant and which is a variable. See, for example, integral of a dx. Okay, or else I will write something like this. Integral of y dx. What do you think is the answer? Y power 1. So apply the formula and tell me, no?
Sir, y power
Y
n plus
square.
1 by n plus 1.
So it will be y square by 2, no?
Yeah. Yes, sir.
Correct? But that is wrong. Why? Because here the variable is here, the term that is given is y, here it is x. This formula x square by 2 would have come only if it is x with respect to x. You're able to understand? Similarly, had it been x with respect to y, what is the answer? I'll tell you what is the answer, but what do you think? Do you think it is x square by 2 still?
No, sir.
No, because you're not integrating x with respect to x. Okay. So if you want me to answer what is integral of x dy, it is nothing but x should be taken out. Only integral of y should be left inside. So it will be x into integral of derivative of something is nothing but the variable itself, x into y. You're able to understand? So out of 80, I took only a outside because the time is a variable and you're integrating itself with time.
Got it, sir.
Sir,
Okay, tell me.
sir,
Tell
in the
me, tell me.
last case, sir, you told that integral of x dy equals x multiplied by integral
Y.
of dy, sir.
Dy.
So,
Yeah.
but here we are assuming x to be a constant, but what if x is not a constant?
No. Here I'm talking about mathematically x and dy. I'm only asking you to check. Forget about physics as of now. With the respect to this example, I'm saying here you have x and here you have y. So integral of x dy is nothing but you should not write it as x square by 2 because you're not integrating x with respect to x. There is a common mistake which people do. Whenever I give them integral of t dx something like this, okay, they start writing it as t square by 2. No, because we don't know how x and t are related, right? So if you don't know the relation, then t can by default be taken as constant and you will take it out. So always when you're integrating, what I'm trying to say is you need to concentrate on the differential coefficient. See, for example, I have a question like this. You know what is integral of sine theta? What is the answer? Or sine x? Check your notes and tell me.
Minus cos x plus c.
It is minus cos x plus c. But if you ask me, I will say it is wrong. Why? Because the question is incomplete. What is missing in the question?
Sir,
The
dx.
derivative.
Derivative.
dx.
Yes. Integral of sine x with respect to x is minus cos x. Okay. Had the question been integral of sine x with respect to d theta, it is definitely not equal to minus cos x. Because the variable here is x and you're integrating with something else, theta. You're able to understand? So whenever you're integrating,
Yes, sir.
right, this differential coefficient is the ignored part by everyone. I don't know why. Okay. Generally, they don't teach it also, but ensure you're concentrating. Whenever somebody asks you what is integral of sine x or integral of anything for that matter, the first question you're supposed to ask is you're integrating with respect to what? It is then your answer will be right. See, for
Sir,
example,
in this case, then can we take sine x out?
yes, you can take it out. Then in this case, it will be sine x into integral of d theta. That will be sine x into integral of d theta will be, by now you should have understood.
Theta.
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 That's it. See, anyway, these kind of things you learn it next year. That's a different story. Okay, but there also it is not concentrated. So I ensure you ask that question. For example, if I ask you a question, derivative of sine x, what will you say? Everybody says it is cos x, right? But derivative of sine x is cos x only when you differentiate it with respect to x. You're able to understand?
Yes,
So
sir.
there is a amount of precision you need to have. You need to be clear with what you're doing. Okay. So I hope I've cleared your doubt.
Yes, sir.
Okay. So we need to derive the third equation. Let's derive it. So what is the third equation? V square minus u square is equal to 2as. So if you observe, this expression is independent of time, right? So we need to consider a mathematical expression which is independent of time for me to proceed with the derivation part. So what I'm going to do is, I will take the definition of acceleration itself. A is equal to dv by dt. The reason why I took A is equal to dv by dt is because the equation has acceleration, the equation has velocity, and final and the initial velocity. But what is missing in this expression? It is displacement that is missing. So for me to get a displacement, what I will do is look at the thing. I'm doing a small manipulation by dividing it with ds and multiplying it with ds. Okay. And the dt is left unchanged. So what I did is a by b, I wrote it as a by c into c by b. That's it. Okay. So a will be equal to dv by ds into what is ds by dt? It is v.
Velocity.
Yes. So what will happen is, observe, v dv, can I write it as a ds? I take the ds to the other side. V dv, I will take it as a ds. Now listen to this carefully. Initial velocity is u, final velocity is v. Initial displacement is 0, final displacement is s. Okay. So integrating on both the sides, what is the initial displacement si? What is the initial velocity va? What is the initial final displacement sf? Final velocity vf, which implies. Now tell me what is the integral of vdv, guys?
V square by 2.
Yes. So v square by 2 between v initial to v final will be equal to a can be taken out, a into integral of ds from s initial to s final. A into integral of ds is going to give you
S.
yes, between s initial to s final. So substitute the upper and the lower limit. So it is vf square by 2 minus vi square by 2 is equal to a into s final minus s initial. So what is vf? V square by 2 vis u square by 2 is equal to a into s final is how much? S minus s initial is 0. So which implies v square minus u square divided by 2 is equal to as, means v square minus u square is equal to 2s.
Sir, could you scroll up a bit, sir?
Sure, sure.
Thank you.
Done?
Yes, sir.
Okay. Now listen to this. We'll do some problems based on the equations of motion and all other things that we have learned till now. Okay. I have told you what is average velocity and average speed. What is average velocity?
Sir,
Delta
S2
XV.
by S1 upon T2 by T1.
That is the total displacement by total time. Similarly, average speed will be the total distance divided by the total time, right? So based on that, we will do some problems. So there is a car which is moving along a straight line, say OP, as shown in figure 3.1. Shown in figure 3.1. Where is it? This is the diagram. Let me copy this. Okay, I will keep it here for the time being. It moves from O to P in 18 seconds. Where is O? O to P in 18 seconds and returns from P to Q in 6 seconds. Okay. What are the average velocity and average speed of the car in going from O to P and from O to P and back to Q? Okay. So what is the average velocity in the first case? So can you tell me what is
360
the
upon
average?
18.
Sorry?
No, sir, 360.
Yes, it is 360 divided by 18, which is going to be 20 meter per second. X is measured in meter, no? So 20 meter per second. Okay. What is the average speed of the car going from A to P? Sorry, O to P. This is also equal to average
20
speed
meter
as
per second.
the same 20 meters per second. Whereas, what is going to be the average speed when the car has gone from O to P and then back to Q?
The 360 plus 120 by 18.
So 360
By 18
plus
plus 6, sir.
by 120 divided by
18 plus 6.
Seems
yes,
like yeah.
18 plus 6, that is 24. So that is 480 divided by 24. How much is it? It is
20, sir.
20 meter per second, right? Similarly, what is going to be the average velocity in this case?
So 240 divided by 24, 10 meter per second.
Very good. 240 divided by 24, that is 10 meter per second. I hope this point is clear to everyone, right? Why is it 240? Because the displacement from O to Q is directly, so the displacement between the points O and Q is the shortest path between them. So when you join from O to Q directly, the displacement is 240, but the time it took is 18 plus 6, that is 24. Okay. Next. Now let's do this problem. So the position of an object moving along the x-axis given by x is equal to a plus bt square, where a is 8.5 meter and B is 2.5 meter per second square. And T is measured in seconds. What is its velocity at T is equal to 0 seconds and T is equal to 2 seconds? What is the average velocity between T is equal to 2 seconds and T is equal to 4 seconds? How to do? So they have asked what is the velocity at, so this preposition at means instantaneous value. If they use the word between, it means it is
Average value.
okay. So that is the language Western physics. Okay. So x is equal to a plus bt square. Now the question is, how will you find the velocity at t is equal to 0? Find dx by dt. What is dx by dt?
2 BT.
2 BT.
It is 2 bt. So they asked what is dx by dt at t is equal to 0. How much is the answer?
0.
0, sir.
0. Similarly, dx by dt at t is equal to 2 seconds. It's 4b. But b is 2.5. So 4 into 2.5, answer will be 10 meter per second. Correct? Similarly, what is the average velocity between 2 and 4 seconds? So whenever instantaneous is asked, the method is differentiate and apply values. Okay. Whereas whenever average values are asked, what are we supposed to do? Substitute the value and then find slope. Substitute the value and then find slope. So x is equal to a plus bt square. They ask between t is equal to 2 seconds and 4 seconds. No. So the displacement of the object at 2 seconds is equal to a plus 4b. The displacement of the object at 4 seconds is a plus 16b. Did you guys understand what I did? I took the value of t and substituted in the place of t. Now, what is going to be the average velocity? Final minus initial divided by final minus initial. So displacement at x is equal to 4 is a plus 16b minus displacement at x is equal to 2 is a plus 4b the whole divided by t final is how much? 4 minus 2. So a and a will get cancelled. 16 minus 4 is 12. 12b divided by 2 is going to give you 6b. So 6 into 2.5 will give you 15 meter per second. Did you guys understand what I did? Is everyone clear with this?
Yes, sir.
Yes.
Yes, sir.
Right. Good, good. Right.
Sir, I have a doubt here, sir.
Tell me.
Sir, we can also do in this method, we can also do in another method, suppose like we find the instantaneous velocity at t equals 2 and then find the instantaneous velocity at t equals 4 and then average them out.
That will not go. You want, you can try and see. You will not get the
Sir,
value
that
because
comes, sir.
maybe for this problem, but that's wrong. If you want, I will do one thing. You can change the limit to 0 to 4 seconds and try. Tell me if the answer is going to be missing. Okay. It will fail mostly because that method is not right.
Okay, sir.
So what you're doing is you're finding something called as relative value. You're not finding, because you find instantaneous value. What are you trying to say? You're only defining the velocity of the object at that instant. See, for example, how much did you get when you found the instantaneous? Okay, here only have no. How much is the instantaneous velocity you got? At t is equal to 2 seconds.
So 20.
You got it 20. What is the velocity you got at t is equal to 4 seconds?
$80, sir.
You got 80. So you did 80 minus 20 divided by 4. And you got 50 because 60 by 4 is 15. Right? So that's what you're trying to
Yes,
say.
sir.
The reason why you're not supposed to do it like this is you found the exact values of velocity at a particular instant. Now the question is, the object is still in motion between this 2 seconds and 4 seconds. So by following this method, I'll tell you what is the mistake you're doing. You're actually ignoring the velocities of the particles between the points A and B. You're able to understand? And luckily, you know why you got the answer right.
Yes, sir.
You know, luckily why you got the answer right? Because this is a condition where the object is under constant acceleration. You can ask me, how did I find it? Okay, that is the reason why your answer matched. If you want, I'll change the question and give. Others can also try and see later. Okay, it's a good question that he has asked. It's better we'll have a learning from that. We'll try to understand why we are not supposed to do. Okay, so I'll tell you what is the question. X is equal to a plus bt square, right? Right. So s
Yes.
is equal to ut plus half at square is there, right? Suppose the initial velocity is 0, for example. For instance, take it as 0. Then can I write s is equal to half at square? Okay. So s is equal to half at square is also an equation of motion of an object under
free fall.
Under constant acceleration. Correct? So if the displacement is dependent on time as a function of square, then you can blindly say that the object is in constant acceleration. So here also the displacement is a function of time as a square. And that is the reason why I concluded it is under constant acceleration. And that is the reason why your answer also was right. Because the object under constant acceleration will move in a linear fashion. When you try to plot it on a graph sheet, you will have a linear fashion. And that is why your slope came out to be the same value. For example, I'll give you another problem. You guys can take it as homework and tell me what is the answer tomorrow. Okay. X is equal to AT plus A plus BT cube. Okay. All other conditions are same as given in this question. Do this using both the methods for average value and let me know if the answer is going to match. You can take your time, do it tomorrow and tell me, no hurry. Okay. Just for you guys to analyze why you're not supposed to. Am I clear till this point?
Yes, sir.
Good. Okay. So I will do problem which is based on the stopping distance. So 3.7, let's do it. Okay. So when brakes are applied to a moving vehicle, the distance it travels before stopping is what we call it as stopping distance. Basically, the word itself is telling us the whole meaning of it, right? Stopping distance. So it is an important factor for road safety and depends on the initial velocity and the braking capacity or deceleration. You know what is deceleration? It is the retardation of the object or negative acceleration, right? And depends on the deceleration minus A, that is fast the braking. Derive an expression for the stopping distance of a vehicle in terms of V naught and A. See, there are two ways of writing initial velocity. One is U or you can write V with a circle at the bottom. You read it as V naught or the velocity at initial instance. You read it as V naught. V naught. Okay. So they're asking us to calculate the stopping distance. So how to find the stopping distance, guys? See, wherever you have, okay, I'm going to tell you one important point and a trick to apply the right equations of motion. Wherever you have a condition where the final velocity of the object is zero, okay, wherever you have a condition where the final velocity of the object is zero, there will be two scenarios that they will ask you. One is they can ask you the time at which the velocity becomes zero. If suppose the question is related to time, then apply the formula V is equal to U plus KT. Okay. Sometimes they will ask you after traveling how much distance has the velocity of the object become zero. So that's for that you apply the formula V square minus U square is equal to 2x. Am I clear?
Yes, sir.
Can you
Okay.
repeat?
So in this, see what I'm trying to say, whenever you have V to be zero, that is the final velocity of the object to be zero at a particular instant. Suppose the object is thrown in the upward direction, they're asking after how much time the velocity of the object becomes zero. Then you apply the formula V is equal to U plus KT to solve it. But whereas if the problem is related to finding the distance, apply V square minus U square is equal to 2as. That is the third equation of motion. Now tell me, here they're asking the stopping distance. Means let's analyze the situation first of all. So here the object of the initial velocity of the object is V naught. And he started applying brake. Okay. The spelling for brake in mechanics is B-R-A-K-E. Okay. Brake, and here the final velocity becomes zero. And they have mentioned one important point that the object is under a constant retardation. Means, so constant retardation is nothing but constant negative acceleration. So wherever you have constant acceleration or constant retardation, you can always use the equations of motion. So can I write V square minus U square is equal to 2as? What is the value of V? 0 square minus, what is U square? V naught square is equal to 2 into acceleration of the object is minus A into displacement of the object is Sx or whatever. I don't know what they have asked. So Sx will be equal to V naught square divided by 2A, and this is going to be the required stopping potential, stopping distance.
Sir, what is that B naught square?
V naught square is the initial velocity square. That's what they're given as a question.
Okay.
It depends on the initial velocity V naught. Okay.
Sir, why are we writing it as Sx?
I wrote it as S6. You just write it as S also.
Like, no, sir. Why are we writing a subscript over there?
Because I took the object to move along x direction. Horizontal is x, so I wrote it as x.
So we can't,
So that
it
is
shouldn't be
just
like S
S.
is equal to.
You can write S also. This x is not needed. You can write it like this also. No harm.
Yeah, okay.
It is just a notation. Okay. Now listen. Let's do some more problems here. 3.3. there is a woman who starts from her home at 9 a.m., walks with a speed of 5 km/h on a straight road up to her office, which is 2.5 km away. Stays at the office up to 5 p.m. and returns home by an auto with a speed of 25 km/h. Choose suitable scales and plot the displacement time graph of the motion. Okay. Listen. So, time. And this is a, let's say it's a displacement time graph itself. X. Okay. So woman starts from her home at 9 a.m. Let's say this is 12 a.m. For instance, let me call this as 12 a.m. So 9 a.m. is somewhere over here. Okay, till 9 a.m. she was at her home. Accepted? So let me take a red color line. Till 9 a.m. she was at her home. And from 9 a.m. what did she do? She walked with a speed of 5 km/h. So wherever you see the word speed, okay, this is another hint. If you see the word speed, then acceleration can always be taken as 0 because speed is the magnitude of velocity. Okay, whenever an object is moving with a particular speed, it doesn't mean, it means it doesn't have any acceleration. Okay, with a speed of 5 km/h on a straight road up to her office, which was 2.5 km away. So this is her home. Where is her office going to be? At 0, 2.5. Right. From here, she has walked till this point with a speed of how much value? 5 km/h. Did you understand why I drew a slanting line? Now
Because
tell me.
time goes, sir.
Yes, time is also
Like-
running. She is also moving parallel. Right. Yes. And she returns. Then what is happening? 5
Yes,
km.
sir.
One, yeah, that's right. But 5 km/h to a
Sir,
distance
we
of
have to
2.
find the time, sir.
Yes, that's what we need to find. How much is the time it is going to take? She's going
Sir,
to take time.
2.5 by 5.
So distance by speed, that is 2.5 by 5. So she took half an hour. So here, if I take time is measured in hour, then at what time did she reach there?
9:30.
30.
So she reached at 9:30. From 9:30 till what time was she in the office? Till 5 p.m. She was at a location of 2.5. Okay. So this was till 5 p.m. After 5 p.m., what did she do? Again, she traveled back by an auto with a speed of 25 km/h. So how much is the time taken now? 2.5 divided by 25. How much is it? It took 0.1 hour. 0.1 hour is how much? How many minutes is this?
6 minutes.
It is
6 minutes.
So in 6 minutes, she returned back to her home. Means at 6 p.m. she was at her home. Did you understand this? It's a good problem. Choose suitable scales and plot the xt graph. So x should be taken in kilometer and time should be taken in hours.
Sir, here we are taking displacement time graph or distance time graph.
It is actually displacement time according to me. It should be displacement time. Okay, why? Because I am taking the distance to decrease with respect to time. You're able to understand? See, this is A, B, C, D. From A to B, the distance has increased. From B to C, displacement is constant. But from C to D, the displacement has decreased. So I'll call it
Yes,
as a
sir.
displacement time graph.
Sir, in case if this was a distance time graph, then after 5 o'clock, we have drawn a line which touches
Upwards.
the x-axis. It will go upwards, right?
It will go upward. It should have been like this. Since you asked that question, it should have been like this.
Okay, sir.
Okay. I hope it is clear,
And
right?
sir, on the x-axis, it should be 2.5, comma 0, right?
Not on x-axis, it is on y-axis. No? This is 0, 2 point. It is y-axis. Huh?
Yes, sir. Y-axis.
X is notation. X doesn't mean x-axis.
Sir, we can take 9 a.m. as the origin, right?
Yeah, you can take it. But I just wanted to show you a different graph because you should not always get used to graph starting from origin. That is the reason I
Yeah,
gave it. This is
okay.
called a shifting of graph. Okay.
Sir, it
You
should
can
be
take it
2.5,
origin.
comma 12, sir.
2.5, 0 should be on x-axis. But this point is where it is on the y-axis. No. Means what I'm trying to say is, you know why you're plotting a graph, you know how coordinate geometry is going to help you. If I take the coordinates of this point, if I tell someone that 9, 0, what will that person understand? If I say the coordinates of point A is 9, 0, 9 corresponds to time and 0 corresponds to the displacement. Means you will understand at 9 a.m. the person is still at home. You're able to understand? So what will be the coordinate of this point?
Yes, sir.
9:30, 2.5. Whereas if you take that as 2.5, 0, what will happen?
Sir, it's wrong, sir, because
Yes.
the x-axis is time.
Yes. Now you understood what is the meaning of this coordinate geometry? That is the reason why
Yes,
you
sir.
draw. Yes. Okay. Next. So there is a drunkard walking in a narrow lane, takes 5 steps back forward. 1 minute. Takes 5 steps forward and 3 steps backward, followed again by 5 steps forward and 3 steps backward, and so on. Each step is 1 meter long and requires 1 second. Plot the displacement time graph of his motion, determine graphically and otherwise how long the drunkard takes to fall in a pit 13 meters away from the start. Time. Here also it is supposed to be displacement. Okay. But here displacement will be in meter, time will be in second. So initially, let's say he started here. How many steps in the forward direction?
5.
5 steps. By the end of 5th step, he would have consumed how much time?
5 seconds.
5
He would have
seconds.
consumed 5 seconds. Right. After this 5 seconds, for the next 3 seconds, he is coming back by 3 steps. So how much is the time he has consumed from the origin?
8 seconds.
8 seconds.
8 seconds.
It is 8 seconds. From the origin, it is 8 seconds. Right. So what is this point? This point will be 0, 5. Now, what will be the coordinates of this point? It will be 0, 2. Why did I write 0, 2? Because 5 forward and 3 backward. So the total displacement he has covered is how much? It's only 2 meters. Right. Now this will be the starting point for the next 5 steps. So from here, how much he would have traveled?
Sir, 7.
7 meters.
Yes. So he would be at a distance of 7 meter. Okay. So by the end of 7th meter, when he is at exactly 7 meter, how much time has he consumed already?
Okay.
Huh?
13 seconds.
Very good. 13 seconds. After 7, again he will come back to
0,
4.
he'll come to 4. So by the end of by the time he completes a displacement of 4 meter, the time he would have consumed is
17.
16. No. After 13 seconds, he takes 3 more seconds to come back. No.
16
Okay, sir.
seconds.
Okay, sir. Okay.
Correct? So 16. It is fine. After 16, again, now where is he? So let me plot everything for your clarity. So what will be the coordinates of this point? It will be 5, 5, whereas this point will be 8, 2. What will be the coordinates of this point? 13, 7, whereas the coordinates of this point will be 16, 4. Like that. From here again 5 more steps. 9. At the end of 21 seconds. So what will be the coordinate of this point? 21, 9. From 21 again he will come back to which point? At the end of 24th second, he will be at a position of
18.
18. 9 steps are over. By the end of 21 seconds, he has completed 9 meters distance. By the end of 24
Six,
seconds,
sir.
he will take
6, sir.
he
6,
will
sir.
be at 6. Yes. 24, 6. After 24, 6, where will he go?
Eleven.
11. 11.
He will go to 11. Okay.
11,
After 11,
27.
yes. So he will be at 11, 27. Sorry, 27, 11. Then he'll come back 8 steps at the end of 27th second. Sorry, 24. 1 minute. Sorry, 24, 29. No. Did I do any mistake? Sorry, in the process of shifting, did I miss something? Did you guys understand what I'm trying to do? So 24 plus the
29
next 5.
seconds.
It should be 29.
29 and he 32. He'll be at which point? 32, 8. After 32, what
Yes,
will
sir.
happen? He will travel.
We'll fall in the pit.
5
fall into the
steps.
pit. Next 5 steps, he's into the pit. So what is going to be the answer? 37, 13.
13.
So at the end of 37th second, he is going to be in the pit. Okay, so this is how the graph will look like. Okay, so next class, what I will do is I will be discussing more on graphs of different scenarios, how you're supposed to draw the graphs and all those things. So revise the topics and come before tomorrow's class. Any other doubt from today's class? Also do this problem and tell me what is the answer. Okay, x is equal to a plus bt cube for the same scenario. Do and tell me the answer by in tomorrow's class. And you yourself verify if the answers are matching. Okay.
Thank
Is
you,
it
sir.
all? Yeah, we can write it.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you,
Thank
sir.
Okay, sir.